Hello, everybody. So here we go. We're doing two problems only. This is applications of law of science. This is important stuff. So we've got these, there's a wildfire here. So please read this paragraph and try to actually pause the video and see if you can construct some triangles here. This sentence right here, after reading through the whole paragraph, I want to start there. Station A is 13 miles due west from station B. So I can just connect these two with the flat horizontal line, and I know that's 13, and my unit is miles. So I never really have to read that sentence ever again, which is pretty comforting. Ranger Rick spots a fire 29 degrees east of north. So east of north. So angling in an eastward direction after you've faced north. So from station A, he spots this, and 29 degrees goes right there. Trooper Tracy spots the same fire 51 degrees west of north from her station. So from her station, if she tilts her head to the west, after looking due north, she will see the fire. She has to tilt her head 51 degrees in a western direction. So how far is everybody from the fire? Well, we don't have a right triangle, so forget any ideas about SOHCAHTOA or Pythagorean theorem, but I can fill in some unknowns. Like I can fill out, I know this one right here, because I know I got a 90-degree angle there, so I can just take 90 minus 29, and I discover that's 61 degrees. And same thing for the other side. This is 39 degrees. Well, I have angle, side, angle. I have an angle, side, angle. And do I have to do law of sines, or can I do law of sines? Remember, you need an angle and its opposite. Well, I can figure out that angle pretty easily just by subtracting from 180. So 180 minus 61 minus 39 gives me 80 degrees. And I want to find out how far is Trooper Tracy and how far is Ranger Rick. So let's actually give these names. Let's call TT for Trooper Tracy and RR for Ranger Rick. That's how far Ranger Rick is in station A, Trooper Tracy is in station B. So let's do some work. So I can do the sine of 61 over Trooper Tracy is equal to what? I need at least one relationship, and this is the relationship I'm going to use because that's the only opposing relationship I actually have. So I'm going to set that equal to the sine of 80 degrees divided by 13. And I can cross multiply, so 13 times the sine of 61 degrees equals Trooper Tracy times the sine of 80, divide by the sine of 80. And, oh, that's funny. Trooper Tracy looks like pi if you're a little bit sloppy. So then I go to my calculator, make sure you're in degrees. 13 times the sine of 61 is 11.3 something. Divide that by the sine of 80, and I discover that Trooper Tracy, let's round it to 2 decimal points, is about 11.55. What's the unit? Miles? I'm assuming it's miles. Miles. So Trooper Tracy, don't forget, station B. So station B, she's almost 12 miles away from the fire. Now I need to find Ranger Rick. So for Ranger Rick, actually I can replace this with 11.55. So for Ranger Rick's situation, I'm going to work with this opposing relationship. So I'm going to start with the sine of 39 degrees over how far Ranger Rick is divided by, I could do the same ratio, the sine of 80 over 13, cross multiply, solve, and I'm just going to use I'm not gonna do work twice. I'm just gonna use this. I know that eventually it's gonna be 13 times the sine of 39 divided by the sine of 80. And yeah, you can do that in the test as long as you show this first. You just can't jump to the end without showing work. It's all about the work. So what do I discover about how far Ranger Rick is? 13 times the sine of 39 is 8.18. Divide that by the sine of 80, and I get 8.31 miles. So now I know a lot of really good information. Ranger Rick, of course, is closer. I mean, we could tell that by the drawing. He is about 3 miles closer than Trooper Tracy. And that was the question. That was the question. How far is each from the fire? And let me. If you're given something in words, you should answer in words. Good night. All right, so Ranger Rick is about 8.31 miles away from the fire. And she was about 11 and a half. So there's the answer to question number 1, but this one has a little extension. They both have Jeeps. Station A's Jeep can only go 20 miles an hour. Station B's Jeep can go 27 miles an hour. Who's going to get there first? How would you even solve that? Station A has a Jeep that goes 20 miles per hour.